Okay, today I present to you the corrections for the class test on linear inequalities. Okay, the first question, the smallest possible value of x over y. So basically, right, if you must also consider that there is a possibility of having a negative value. So if I choose my x value to be negative 5 and my y value to be 3, the smallest possible value is negative 1 and 2/3. So remember that it is possible to choose negative values. For 1b, the largest possible value of x squared minus y. Okay, same thing. Many of you have chosen 4 square minus 3. And your answer is 13. But however, this is actually incorrect. Why is this incorrect? Because of the 4 down here. Why? If you notice, right, you can actually use negative 5 square minus 3. Negative 5 square will give me 25 minus 3 is equals to 22, which is even larger. So this is actually wrong. So it's negative 5 square minus 3. So take note that it's possible to choose negative values. Okay, the next one is question 2, which is the expressing the thing on the number line. Okay, solving the simultaneous linear inequalities. So the first one that we do is that you have to split the inequality. So I write minus 1 minus x over 4 is lesser than or equals to x plus 3 over 4. And also I have x plus 3 over 4. Okay, so I have to split the inequality, and it's lesser than 21 minus x over 2. Okay, here this one's simple enough. I multiply both sides by 4. I get negative 1 minus x is lesser than or equals to x plus 3. Okay, rearranging my equation, negative 2x is lesser than or equals to 4. Dividing by negative 2, be very careful. Okay, you must change the direction of the inequality sign. X is greater than or equals to negative 2. Similarly here, I multiply both sides by 4. I get x plus 3 is lesser than 2 times 21 minus x. So what I get is x plus 3 is lesser than 42 minus 2x. 3x is lesser than 39. X is lesser than 13. Alright, here is where we will have to draw out the number line. Okay, so it's best that if you can actually find a ruler, okay, use a ruler to actually draw the number line. I can't find a ruler now, I shall use my card here. Okay, so first I will draw like this. Okay, negative 2 and 13. So this first inequality here, x is greater than or equals to negative 2, I draw with a black dot, means that it is inclusive. This one, x is less than 13, I draw. I get this one, x and x. So if you look for the intersecting portion, which is over here, what I get is negative 2 and 13, like this. And this portion here is my final solution. Okay, next one is this prime numbers. Okay, what are prime numbers? Prime numbers, okay, are numbers which can be divided by, can only be divided by 1 or itself. Okay, first thing you must take note is 1 is not a prime number. So therefore in this case, right, what we have is x is greater than or equals to negative 2 and lesser than 13. The first prime number that we have is x is equals to 2. 3 is possible, 4 is not prime, 5, okay, 6 is not prime, 7, 8, 9, 10, 11, okay, 12, 13 is not inclusive. So for 2b, the prime numbers are 2, 3, 5, 7, 11. Many of you wrote 1 as a prime number. 1 is not a prime number, so take note of that. And that concludes the corrections for the class test.